The last lesson of this unit, we're going to look at how we can analyze graphs and how we can draw graphs without actually using the graphing calculator. So that little chart there just sort of gives you a summary. It says nearest factors, solutions, and intercepts. So this is sort of just summarizing everything we've done this unit, and we're going to put it all together. So 0, k is just some number. K is the zeroth of the polynomial function f. So 0 means it's a factor of the polynomial. The factor itself is x minus or x plus that number. So the value itself is 0. X minus or x plus the value is the factor. The solution. K is a solution of the polynomial equation f of x equals 0. That's just how you write it. And x-intercept. If k is a real number, k is an x-intercept of the graph of the polynomial function f. The graph of f passes through k, 0. So k is a value, but it's also saying that because it's 0, that means it's passing that value, passing through that value on the x-axis. So let's take a look at these graphs. It says the y-coordinate of a turning point is going to be a local max. So it's local max of the function if the point is higher than all nearby points. And it's going to be a local min if the turning point is lower than all your nearby points. So it gives you an example. So turning points is where you're changing directions in the graph. So we're going up, 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 then we turn and go down. Then we're going down, 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 and we're going up again. So let me give you guys another example. And you guys know what mins and maxes are. So your mins be here, here, and here. And your maxes would be these three. So those are your turning points of the function. They're going to be important when you guys are trying to identify what degree this polynomial is. So that leads us to our next concept. It says turning points of a polynomial function. The graph of every polynomial function of degree n has at most n minus 1 turning points. So if a polynomial function has n distinct real zeros, then its graph has exactly n minus 1 turning points. So if you have a polynomial of degree 3, you would have 2 turning points. You can't have more than 2 turning points. If you had something to the 7th power, you could have no more than 6 turning points. So the degree tells you how many turning points are going to be in your graph.